Alright, we are now on question number 6, and you can pause the video and try this. Okay, let's go. Now, this is the beam uniformly distributed, but we have 2 hinge, 1 and 2. We have hinge at point E and hinge at point F. So the first thing you are going to do is to break it down to separate the beam. And if you are going to separate this, you separate from this point to this point. That is one beam. From this point to this point, that is another beam. From this point to this point, that is another beam. So it means we are going to separate it into what? Into 3. So it means it's going to be like this. It's going to be like from A to E. Going to be in form of something like this. We have our hinge support here, have our rolling support here, then we have point E here, point E. I hope you are following. So this one is 200, this one is 50. So we have our uniformly distributed load in this manner. So this one is going to be in this form. So we have our E here, we have our point F here. You see that? So the distance is 150. So we now have F to what? D. F to D. F to D. Let me put this like this. You can see that. So this is F. This is a rolling support. This is also a roller support. So the distance from here to C and D, FC is 50, CD is 200. And don't forget the uniform distributed load is nothing but what? 2 Newton per meter, 2 Newton per meter, 2 Newton per meter. And don't forget we have a point load acting on this part at a distance of what? 30, which is 200. Yes, so this is how we are going to separate this. Now the next thing is our force. We should assume our force. Let's assume an upward reaction for this. Let's also give this upward reaction. So if it is like that, it means if we have something like this here as our HE, this one is going to act like this as our HE. This one is going to act like this, and this one is going to act downward. Arrow E. So if we have this like this as our HF, this one will be our arrow F. So if this one is upward, this one is going to be what? Downward. So this one is going to be like this. HF. How to get this? I'll explain this. So now the next thing is to calculate our reaction now. Now, are we to start with this? Are we to start with beam A, B, and E? Or are we to start with this, beam beam F, C, and D? No, we are going to start with this. We'll get the internal forces first. When we get the internal forces, then we'll now consider this and that. Okay, so now let's start with beam EF. I will be drawing the free body diagram. The first thing is to convert the uniform distributed load to a point load. And if you want to do that, area is what? Length times breadth. And length here is 150 times the breadth, that that is 2, which is 300 kilo Newton. Is it here? Okay, sorry, not in kilo. 300 Newton. Do you understand? And it's going to act at what? Half of the what? Center. And which it it's going to act at what? The center of the what? B. So it's going to be like this. Let's assume this is it here. That is 300 Newton. Don't forget this place is going to be 75. And don't forget we are also having 200 Newton here. Acting at what? Acting at a distance of 30. So like this. So we now have a upward force here. Also have a upward force here, which is arrow E and arrow F. And this place we have a vertical force, that is HE, and what? Also have a horizontal force here, HF. So I think that is everything about that. So now the next thing is to calculate our horizontal force, vertical force. So horizontal force we assume according to the positive summation of S to be equals to what? 0. So it means that you see this one is pointing in this direction, is in alignment with this. So it's going to be HE, but this one is in opposite direction, minus HF equals to what? 0. So here you can conclude that HE is equals to, if you come back, it's going to be what? HF. But they are both equals to what? 0. Okay, the next thing is to calculate our what? Vertical force. So summation of Y force equals to 0. So what are the vertical force that we are having? We have this and this as our upward force, which is positive. So it means arrow E plus arrow F. Then the next one is minus 200 minus 300 equals to what? 0. So it means arrow E plus arrow F will be equals to minus 200 minus 300 is minus 500. When it comes to the other side, it becomes positive 500. Equation what? 1. So the next thing is to take my moment. I'm going to take my moment about point E. Take my moment, that is clockwise moment, about point E equals to 0. So this is where I'm going to put my hand, then I'll be left how many force? 1, 2, 3. So don't forget that downward force will give me a positive moment. Positive moment, while this upward will give me a what? It's going to give me what? Anti-clockwise. It's going to be what? It's going to be an anti-clockwise moment. But downward force will give us what? A clockwise moment, which is in alignment with this. You can see it like this. It's going like this. So which is be positive. So let's start with this. This one is with 200 times the distance it covers is what? 30 plus we are going to have 300 times the distance it covers is what? 75. You know it's acting at half of the center. You understand? Starting at half of the center. So from here to here is 75. From here to here is what? 75. So which is what? Times 75 minus arrow F times the distance, which the total distance is what? Is 150. So which is equals to what? 0. So from here, if this times 150 go to the other side, it's going to be what? 150 arrow F equals to 200 times 30 plus 300 times 75. What that is going to give us? Let me press my calculator. 200 times 30 plus 300 times 75. That is going to give us 28,500. 28,500. Yes, it's correct. So now, for me to get my RF now, I'll divide both sides by what? 150. So it means RF will be equals to 28,500 over 150. So this one will give us, if I divide this by 150, that will give us 310 Newton. 310 Newton. Yes. Let me divide it by 150. Oh, sorry, that is 190 Newton. Yeah. Sorry, I thought it's 190 Newton. How do you get that? Please, I'm sorry for the mistake. Okay, so now the next thing we are going to do now is to calculate what? Is to calculate our ROE. ROE. So can we get our ROE? Yes, we can get our ROE using equation what? Equation 1. From equation 1 we have ROE plus ROF. So it means ROE will be equals to 500 minus what? ROF. 500 minus ROF, which is 500 minus what? 190, because ROF is what? 190. And that is going to give us what? 310. Yeah, I assumed the answer for this. So sorry. So it's going to be 310 Newton, right? So that is ROE and what? ROF. And you can see that our answer is what? Positive. So it means our assumption is what? Correct. So the next thing we are going to do is, since we've gotten the internal forces now, we can now take beam A, B, and E now. Let's solve for beam. A, B, and what? A, B, and E. A, B, and E. Okay, so now we draw the free body diagram again. Free body diagram will be in this manner. This one is a hinge here. Look at this, it is a hinge. So, which is going to have what? Two reactions. ROA and what? HA. So, we have a roller support there. It's going to just give us what? One reaction, which is what? The vertical reaction, ROB. And here we are having this as a downward force. So, which is downward like this, which is a ROE. Right? So now we're also having this one like this, which is what? HB. So from here we'll convert this one to a point load, the uniform distributed load. So which is nothing but what? 2 times the total distance. Here is 200 plus 500, that is 700. So 2 times 700, which is what? 1400, right? And which is going to act at where? The center of this beam. Let me clean this one. So it's going to act at the center. That is this one is 50. The distance here is 50. Sorry for that. The distance here is 50, not 500. Look at it, BE is 50. So the total distance there is what? 200 plus what? 50. That is 250. So 2 times 250. 2 times 250 is 500. So we are going to have 500 Newton here, acting at the center of the what? Of the beam. So 250 divided by 2. I think that is 125. 125. So it's going to act at 125. 125. 125. So now we now have this roller support here as our downward arrow what B. But don't forget that the distance of the roller support, okay, let me do this like this so that you will not get confused. From this point to this point is 125. This point to this point is 125. How to get this? So, but the distance from A to B is what? 200. 200, right? This one is what? 50. This might be here. You understand? So now, this next thing also is to calculate our what? Horizontal force. If this positive equals to what? 0. So it means that HA, which is in alignment with this, will be positive, minus HE, which is in opposite direction, will be equals to 0. So it means HA will also be equals to what? HE, but they are both equals to what? 0. So the next thing is to take our what? Our vertical force. So summation of vertical force should be equals to what? 0. I hope you are following. So now the upward force I've given it to be what? Positive. So how many forces do we have here? That is upward is arrow A plus what? Arrow B minus arrow E, which is downward, minus 500, which is equals to what? 0. But don't forget, we've gotten our arrow E. Our arrow E is what? 310. So arrow A plus arrow B, arrow A plus arrow B minus 310 minus 500 equals to what? 0. So it means that arrow A plus arrow B will be equals to what? Will be equals to, if you add this one together, I'm going to get negative 810. So when it goes to the other side, it becomes positive 810. So I can call this one my equation 1. Then the next thing is to take my moment. I'm going to take moment about point what? Point A. You can decide to take it about this point or this point. We still arrive at the same answer. So equals to what? 0. So now the next thing here, when I take my moment here, don't forget that downward force will give me what? A clockwise moment, which will be in agreement with this. But upward force will be what? Anti-clockwise, which is against it. That is negative. You get that? And I have two downward force here, 500 and what? Arrow B. So this 500 is covering a distance of what? 125. So it's going to be 500 times 125 plus arrow E, and arrow E is nothing but what? 310. So it's going to be 310 times the total distance, which is what? 250, minus arrow B times the distance is covered is what? 200. So equals to what? 0. Arrow B times 200 is 200 arrow B minus 200 arrow B. When you cross to the other side, it becomes what? Positive 200 arrow B, which is equals to what? 500 times 125 plus 310 times 500 times 125. 500 times 125 plus 310 times 250. Yes, that is 140,000. So now the next thing is arrow B will be equals to 140,000 over what? 200. So these two, we cancel these two. 2 here 1, 2 14 7. So we left with what? Arrow B to be equals to what? 700 what? Newton. That is my arrow B. So can I get my arrow A? Yes, I can get my arrow A. So it means that arrow A will be equals to what? Will be equals to 810 minus what? Arrow B. And which is 810 minus what? 700. So arrow A will be equals to 810 minus 700. 810 minus 700 is what? 110 Newton. I hope you get that. So the next part now is to solve for this part. Okay, so let's solve that one there. So I'll draw the free body diagram also. Don't forget that the total distance is also what? It's also what? 250. So I think it will be in this manner. It will be in this manner. So draw your this thing first. Convert this to a point load. It is still 500. 2 times 250 is what? 500. So it's going to act at what? The center of the what? Of the beam. So this is 500, right? So 500 Newton. 500 Newton. It's going to act at a distance of what? At a distance of 125. 125. Do you get that? So 125, 125. Okay. So now we are having arrow F here as a what? Downward force. Arrow F. We are having our rolling support here, which is covering a distance of 50. So it's going to be arrow C. You know, a roller support. When you are drawing the free body diagram, is going to be what? A vertical force. I've already explained all this in my previous video. You can check that also. So see, this one is the distance from here to here. This one is give us ROD. ROD, distance from here to here is 200. Distance from here to here is what? 50. So we have vertical, we have horizontal force HF and what? Okay, just only HF. So the first thing we are going to do is to find our vertical force. So summation of F of S will be equals to 0. So it means HF is what? 0. So the next thing we are going to do is to calculate our vertical forces. Sum of vertical force equals to 0. And my coordinate should be what? Upward force should be what? Positive. So it means and I'm having two upward force here, ROC plus what? ROD minus all this downward force I'm having ROF minus 500 equals to what? 0. But don't forget, we've gotten our ROF. ROF is nothing but what? 190. So it's going to be ROC plus ROD minus 190 minus 500 equals to what? 0. So ROC plus ROD will be equals to minus 190 minus 500 is what? 690. And cross to the other side becomes 690. Equation what? 1. So the next thing is to take my moment about what? F. So I'm taking my moment, I'm taking clockwise moment to be positive about what? F equals to what? 0. So if I'm doing this, it means that I'm having how many forces? 1, 2, 3. Downward force will give me what? A clockwise moment. So let me start with that. It means 500 times the distance is covered is what? 125 minus ROC. ROC times the distance is covered is what? 50. So 50 minus ROD. ROD times the total distance is what? 250 equals to what? 0. I hope you can see this. So let me clean this part. Let me clean this line here. Okay. So this is 500. So now it's going to be 500 times 125 minus. So let me write it again. 500 times 125. 125 minus ROC. Have we gotten anything like ROC before? Let's check. Let's cross check. Do we have ROC here? Okay, we don't have ROC. So it's going to be ROC 550 ROC like that. 50 ROC. What of ROD? We've not gotten anything like that also. So it's going to be minus ROD minus 250 ROD equals to what? 0. So what we are going to do now is to move these two to the other side. That will be positive. So it's going to be 50 ROC plus 250 ROD equals to what? 500 times 125. 500 times 125. 500 times 125 is 62,500. 62,500. 62,500. 62,500. Okay, so if you do this, this is what you are going to arrive at. So this one is our equation number 2, right? But you can see we can reduce this by dividing 2 by 50, right? So if we do this, 50 in 50 you can divide everything. We are going to have ROC plus what? 50 in 250, that is 4 ROD equals to 50 in 62,500 is 1,250. Yes, equation number 2. So if you look at equation 1 and equation 2, we can solve them simultaneously. So if we are solving that, we are going to have equation 1. What is my equation 1? It is ROC plus ROD equals to what? 690. Equation what? 1. And equation 2 is ROC plus 4 ROD equals to 1250. Equation what? 2. So let's use elimination method. So we subtract equation 1 from 2. ROC minus ROC will cancel out. ROD minus 4 ROD, that is minus 3 ROD equals to 690 minus 1200. 1250. 690. That is 560 minus 560. So this will cancel out this. Then ROD will be equals to 560 divided by what? 3. 560 divided by 3 is 186.66. 186 ROD is equals to 186.666. You just approximate to 7 like that. So that is ROD. Can we get ROC? Yes, we can get ROC. We can choose any of these equations and we get our ROC. But I'm going to choose equation 1. From equation 1, my ROC will be equals to what? 690 minus what? ROD, which is minus 186.67. So 690 minus 690 minus this, that is 503. So it means ROC is equals to 503.3 units. So here ends our solution. Please, if you enjoy the class, please don't forget to like, comment, subscribe, and share with your friends who might be in need of this. Thanks.